So welcome back to series or on experiment 16, emitting a pulse. So we have something a bit different today. Get this little chip over there. This is a integrated circuit. It's basically just it's kind of like a circuit with inside a very small package, a pre-built circuit inside a package. Some of them you can't replicate without having an integrated circuit. Like this is a 555 timer, which I'll get into in a moment. Some of them you can replicate, like you can replicate this, but some of them have special semiconductors, the same things in transistors, that work a very certain way. So, not a very certain way, but just in a way that you can't get otherwise. So, this is a 555 timer. A 555 timer, well, it keeps time. Or it can emit a pulse. I'm reading off something else here. Just give you a moment. Yeah, no, okay, 555 timer emits a pulse. It's got 8 pins. You can explore that on your own. It's not an easy thing to understand, but there's specific ways to make things, let's say blink, or you can make things go on for a certain period of time using internal resistance, which you adjust by adjusting the external resistance and capacitance and other things you can vary it up with. So, we have a potentiometer. I'm just going to go over this circuit. I'm not going to get into everything. We've got a potentiometer here. In fact, let me zoom out a bit so you guys can see it, so you can see it yourself. I think that's a good view. We've got a potentiometer hooked up to a button, which, as we can see, is hooked up to the second pin of the 555 timer, going from the notch left, 1, 2, 3, 4 down, and then 1, 2, 3, 4 down, 5, 6, 7, 8 up on the right side, because there's a little notch there. You probably can't see it. If I turn my light on, I can. You can see that notch, kind of in the left. We have the potentiometer hooked up there. We also have, so the first pin, I have the breadboard flipped over though today actually, because I need it this way. I need the negative and the positive reaching a little bit further, just for convenience's sake. In this circuit. Otherwise, I'd have to do a lot of crossing over. It's annoying. We also, going to our second pin, we also have a resistor going to the positive. On our first pin, well, by the way, we just have it going to we just have it grounded, going to negative. Also, okay, so on the third pin, we've got the anode of a LED, which is attached to a resistor, which is attached to ground. On the fourth pin, we have another resistor going to positive. And over here, you could say I cheated. Also on the fourth pin, we've got something going to a button, which is grounded. You could say I cheated here. I didn't, but I didn't have enough room under these resistors, so I did what's called busing, which is just simply moving a line down, moving something somewhere else where you have more space. That's all busing is. A lot of things in computers is just busing. The most complicated thing in a computer, in like well, let's say for example, listen, in my computer, underneath that heatsink is my microprocessor. Inside that microprocessor, there is a lot of transistors, and they're arranged a certain way, and it's just and a lot of it's a pattern being a very, very simple pattern being repeated. So and we can make transistors so small, but you think, why isn't it so small? Well, things have to be hooked up in the right order, and there is physical space taken up. So you've got to use a lot of wires to bus, and busing is sometimes the hardest part of a computer. There's a part of the computer that makes you could speed your computer up by speeding the busing up. So it's very, very important. But here it was just for simplicity's sake. I could have done it over there, but I felt like busing, which is something you don't normally hear. So we've got these bussed. So the first line on the left is the first line to the right is our pin 5, and going to the left, it goes up to pin 8. So, I'm going to call the one on the right pin 5, because that's what it is. So, pin 5 it's hard to see, is hooked up to a capacitor, which is hooked up to the ground. That capacitor is going to fill. We know how capacitors work. Oh, okay. Yeah, I was getting messed up there. You can see here that pin 6 and 7 are connected, and that's a good thing because we don't need them to be non-connected. Pin 6 has a capacitor attached to it, which is attached, as we can see with this wire, to the ground. It's going to fill and empty too, but a lot slower than this one. We also have a resistor here, going to positive. And over here we simply are going to positive because that's the power for the thing. We also have another button over, I got over that, went over that button. And over here we've got a capacitor essentially going from negative to positive just to even out the flow. This is very important in anything involving integrated circuits. Integrated circuits are sturdy, but they're sensitive at the same time. Having this thing here to even out the flow is very important. I take this out, parts of this circuit will burn out. So, getting right into what it does, the 555 timer, I told you how that works. So in this case we've got a potentiometer, which is variable resistance, as you know. We've got two capacitors affecting the circuit and a few resistors. Now there's calculators online to find out explain exactly which type of wiring you need to do on a particular 555 timer application. Lots of people use it just to make a blinking light. You use very specific resistances to get specific hertz or flashing rates per second, amounts of flashes per second. It's there's a few common ones, but if you want to get something specific, you're going to have to get specific resistors and specific capacitors, because it's not that specific, but if you don't have them if you don't have things timed correctly, if you don't have the correct resistances, it'll mess it up. It may not blink at all. So this is supposed to be, the reason that pin is bent out is because I don't need it. This is supposed to be a 5K kilo ohm potentiometer. I don't have one of those. I somehow failed to get one of those. I'm not sure how. I went to the store today and they didn't have any either. So that kind of stinks. So we've got a 10K here. I do have a 5K, but it's really long and I don't know how to use it really that well. We've got a 10K here. I've found using my multimeter where 5K approximately is. It's approximately right there. So take my word for it that is 5K. I think the light's on. No, it's not. Okay. So, we're going to see what happens to this LED when I press the first button. Excuse my computer being right there. It just is. Alright. So, we're going to see what happens. We are at the 5 kilo ohms on here. I'm going to press the button and we're going to see what happens with the LED. Absolutely nothing. This means the resistance is pretty high. So, I'm going to adjust this thing carefully to about, let's just say about right there. I'm not sure what that is. I think that's probably about 3 kilo ohms. Let's see what happens. We've got nothing. By the way, I forgot to tell you, this battery is plugged in. Let's lower it a little bit further. We want to go pretty slowly at this point. I'm going to go to right there. Nothing. Nothing. I tried this earlier. It's pretty particular. And there we go. It's lit. You'd say, what's so special about that? Well, the fact of the matter is we did push a momentary push button and it turned on. And it turned off by itself without me doing anything. This is still connected. Here, I'll show you. So, something's obviously going on here. We've done this sort of thing before. We've made things flash with capacitors, but this is not turning back on. You see that this is not turned back on in the time that it's taken to fill and empty. And it won't turn back on. It's how this is supposed to work. It's that little 555 timer that's doing that. All these things are affecting the 555 timer, and it does kind of boil down to the emptying and filling of these capacitors too, but it really is this little microchip that is just, I think it's 11 NPN transistors and 10 PNP transistors and a lot of other things in there. You can make your own 555 timer if you want to out of smaller semiconductors, but it's way easier to use it like this. So that's pretty cool. It lit up for a period of time and stopped once we got to a certain lower amount of resistance. It lit up. Let's go further and see if it lights up longer. Let's just make sure it's not just capacitors here. Let's make sure that this chip is doing something. So it's on. Resistance is now 0, so it should be. Yep. If it really was affecting it, it would be on for just a moment because the resistance is now basically 0. So it is this little chip. It has a threshold, which is pretty cool. Now, you might be wondering what that other button does. I can stop it whenever I want. So that wasn't just a short time. Doesn't matter what happens, it's grounded, so that's cutting out the power. You can see that, just that pin, the 555 timer is kind of like the kill switch, except not. So, yeah, if you want to find out more about 555 timers, you can look it up online. I don't understand them fully yet either, so it's kind of embarrassing, but yeah, thanks for watching. We'll see you next time.